Hi, in this lesson, I want us to look at the evidence that Alfred Wegener assembled to support his theory of continental drift. I'm showing you this image because this is, if you like, a modern take on Pangaea, the supercontinent that existed between about 300 million years ago and 200 million years ago. In fact, to show, if you like, how a modern version of that would look, with modern countries superimposed on the continental fit that Wegener himself proposed way back in 1912. He's the one who came up with this word that means the whole world. Wegener's theory of continental drift was absolutely revolutionary. The thing that really makes it stand out for us today as geologists is the breadth of the evidence that he collected. Let's have a look at a few different pieces of that evidence. This is the first one. I've called this the geological jigsaw, the fit of the continents. In particular, Africa and South America are the ones that perhaps show this most starkly. So how do you think this shows evidence for continents moving apart? There are some issues, though. If you look at the map on the right, you'll see that there are some places where there are gaps between the continents and some areas where we get a bit of overlap between them. It's not quite a perfect fit. Why do you think that might be? Does that in itself disprove the idea of plate tectonics? Write down your observations on page 5 in terms of what it tells us, and also perhaps any issues with that, and can we explain those issues? The second piece of evidence gets a little bit more into the geology of these two continents. We see here South America and Africa together, and we've got a couple of sort of more detailed bits of information about the geology of these two areas. We've got some areas of these continents that are over 2 billion years old. We call them cratons. They're ancient lumps of continental crust. What do you notice about these areas on these two continents? We also have mountain chains that were formed in a plate collision 500 million years ago, so before the formation of Pangaea. Think about what the distribution or the spread of those mountain chains across the two continents would actually suggest. How likely is it that these things occur by chance? Our third piece of evidence that Wegener suggested was fossils that are found in these southern continents. If you look at there are two things to look at with this piece of evidence. Firstly, it's where the different fossils are found. And these are found in rocks of the same age in these different continents. Secondly, and perhaps really importantly, we need to think about how these organisms would have lived. 3 of these, Cyanoognathus, Lystrosaurus, and Glossopteris, could only have lived on land. What type of environment do you think Mesosaurus lived in? Also, perhaps what climates might these have lived in? What climates do these places have now? What does this tell us about continental drift? Does this give us the key piece of evidence? Or are there other ways of explaining these distributions of these particular fossils? Write your ideas down on page 7. Finally, at the end of the Carboniferous period, so this is about 300 million years ago, just as Pangaea had come together, there was a global cooling of the climate. We saw a very big, very intensive glaciation. Now, glaciers deposit very distinctive sedimentary rocks. You might remember that from theme 4. Also, they scratch the bedrock as they move, and we can actually work out the direction that the glaciers must have moved. We find glacial sediments and glacial scratches across all of these continents in the distribution we can see there. What does this suggest about the distribution of these continents when this glaciation occurred? Think as well about the climates of each of these places now. Write your ideas down on page 8. So, it's time to press pause and have a go at the activities on pages 5, 6, 7, and 8. See what you come up with.